for it. Okay, welcome to Math 60. Let's talk about absolute value and square roots. So the absolute value of a number is its distance from 0. That's a 0 right there. 0 on the number line. Distance is always positive. You're right. It's always positive. Okay? Because if you think about it, like, can you drive your car in reverse and take miles off your car? So even if you go backwards, it's just really dangerous. By the way, I would not recommend anyone do that. So, do you remember Cameron and Ferris Bueller? They thought that if they propped up this fancy car and they just put it in reverse, they were going to take miles off the car. If you haven't seen Ferris Bueller's Day Off, then that's your assignment this weekend to catch up on your, pop culture math references here. Distance is always positive. So when we say the absolute value of negative 10, and that's what, by the way, these symbols, these two parallel lines next to the number, are symbols that mean absolute value. So they're saying, well, how far away is negative 10 from 0? What's the distance? It's still 10 units away, so that's positive. Here, the absolute value of 10 is also 10 because it's still 10 units away from 0 on the number line. So we're looking at this distance here and this distance here. Just like it doesn't matter which direction you go in, the absolute value is its distance. Okay, so what's the absolute value of negative 6? 6. What's the absolute value? What's the negative or the opposite of the absolute value of negative 16? Yeah, this one is negative 16. So this is different than negative 16, which you were just doing problems like this. This would be, what's the opposite of negative 16? Positive 16. But you see the parentheses are different than the absolute value, right? Now here, this is telling me the absolute value still can group things together. So this problem is saying, do what's inside and then take the absolute value of it. So what's negative 11 minus 6? Negative 17. Now we want to take the absolute value of that, which is 17. Good. Here, I'm going to multiply whatever comes out of the absolute value by negative 2. That's what it means that the negative 2 is right next to it. It means multiply. So let's go inside first because these act kind of like a grouping. Negative 2 times the absolute value of what would that be inside? Negative 9. Now take the absolute value of negative 9. What's that? 9. So you get here, what do you get? Okay, any questions on that? Let's talk about square roots for a second. So what is a square root? A square root, well, if I have a perfect square, imagine that as a perfect square. And I wanted to find the area. So this square is 4 by 4. What's the area of the square? It would be 16. Because the area is going to be 4 times itself, or 4 squared. Now, if I want to know what did I multiply by itself to get 16, the opposite, the inverse of the square is the square root. So we have this symbol. It's called a radical sign. Radical sign. And we say the square root of 16 is 4 because that's the number times itself. So the square root is the inverse of the square, right? It's the opposite. Just like what's the inverse or the opposite of adding? Yes, opposite of adding is subtracting. What's the opposite of multiplication? Those are what we call inverse operations because they undo each other. So the inverse of square is square root. What number times itself gives you 81? 9. What number times itself gives you 100? Yes, and this negative means I want the word opposite. I want the opposite of the square root of 100. I want negative 10. Okay? What about this one? Negative, what times what gives you 144? 12. What times itself gives you 49? That's okay. That's an improper fraction. It's reduced. It's fine. You can leave it like that. Okay, and the negative comes out in front. What about this one? The square root of 136. What would you have to multiply it by itself to give you 136? 1/6. Great. Okay, let's talk about the square root of negative numbers. So can you take the square root of a negative? Why not? Okay, because if you do 6 squared, you get 36. If you take negative 6 in parentheses squared, what do you get? Yes. So here we say this is not real, and on WebWork, it'll be does not exist. You'll see the instructions does not exist. Use DN or DNE for does not exist. What do you think about this one here? Same thing. Does not exist. Why don't these negatives cancel each other out? I thought a negative times a negative is a positive. Well, because we have to do the square root first, and we can't take the square root of a negative number. So always when we try to take a square root of a negative, we will have not real. Later on in your higher level math classes, you will learn about imaginary numbers, which are denoted with a little I. That will come up later for square roots of negatives. Did you have a question?
Yeah. Also, like on the test or paper, can you write DNE for that, or is that just the web words?
I'll accept it. I'll accept it.
What else is acceptable?
Not real would be another option. You could write DNE or not real, but since you're practicing that in WebWork, sure, I'll take that. I might look at it and be like, what are they talking about? Then I'll remember. Okay. Now we're going to talk about finding square roots with a calculator. Here's the thing we're going to talk about later the difference between rational and irrational numbers. Okay. So those are two different concepts. When I take the square root of a perfect square, I get a rational number. When I take the square root of a number that is not a perfect square, I get what's called an irrational number. Now they're saying round your answers to 4 significant digits, meaning that you want to have non-zero numbers. Well, there's a whole thing about significant digits. I would have to read up on the definition, but essentially we're going to round to 4 digits. Use the calculator to approximate the following. So why don't you know the square root of 10 off the top of your head? Because 10 is not a what kind of number? Perfect square. It's not a perfect square, right? The perfect squares, in fact, what are the perfect squares? 0, 1. 1 times 1 is 1. 2 times 2 is? 3 times 3 is? 4 times 4? 25. Do you know where I'm getting these numbers? 36. What's the next one? 49. 64. 81. 100. 121. 144. Okay, now I'm just showing off. I could keep going. 169. 196. 225. Okay, anyway. I used to make my students memorize. I would have a chart in my room, and I would make them memorize all the way up to 25 squared. 25 squared, 625. It's helpful. It's useful. Just like knowing the times tables is useful, knowing the perfect squares is useful, knowing some of these math patterns. So the square root of 10, it would fall in between since this is 3 squared and this is 4 squared. Can you approximate? What do you think? It's going to be a decimal. What's the square root of 10 going to be about? Between what two numbers? It's going to be between 3 and 4. So it's going to be 3 point something. Do you know why I'm saying that? Because the square root of 9 is 3. The square root of 16 is 4. The square root of 10 is in between. So if I use my calculator and I go the square root of 10, I'm going to get 3.16. Does it kind of make sense? And then this decimal, because this is an irrational number, this decimal actually goes on for infinity. Do you know the most famous irrational number that goes on for infinity that doesn't have a repeating pattern? Pi, yes, pi. And what day do we celebrate Pi Day? March 14th, 3/14, because people approximate pi to be 3.14. We'll get there. We're going to talk about pi more when we get to circles. Okay, what do you think about this one? The negative square root of 80. It's going to be in between what and what? Yeah, it's going to be in between 8 and 9. So when I do the square root of 80, I'm going to get 8.9 because that's really close to 9. And so this one is 8.944, rounded to 4 decimal places. Oops, I forgot to write that one down. Square root, oops, that's not the right one. Square root of 10, 3.162. That's 4 digits, right? And we use an approximate symbol because approximate means it's not exactly equal to that. What about the square root of negative 72? Oh, you're right. This is negative. Sorry. Again, I make mistakes. I'm so glad I have 30 eyes on me to find them. What happened just now? I put in the square root of negative 72. It's not real. Because why? Okay. So go ahead and write yourself your personal reflection. Here are the practice problems that hopefully you did with your classmates. And we're going to go over the practice problems, but we're not going to put them all on the video because I think this video has actually gotten really long. So I'm going to stop it now. Oh my gosh.